Now the 5 steps here are essentially to use the leading coefficient test to determine the end behavior, to find the x-intercepts including their multiplicities, to find the y-intercept, to use symmetry if applicable, so check to see if it's an even or odd function, and then to use the fact that the maximum number of turning points is 1 less than the degree to check to see if it's drawn correctly. So let's start with our leading coefficient test. Here our degree is 3, which is odd, and our leading coefficient is 1, which is positive. So an odd degree with a positive leading coefficient is going to go down on the left and up on the right. And so somewhere out here on the left is going to go down, and somewhere out here on the right is going to go up. Okay, to get an idea of what's happening in the middle there, let's start by finding our x-intercepts, and so that's replacing f of x with 0. Now these two terms have an x squared in common, so we'll factor out x squared. And because that's squared, I could write it as x times x to really get my factors in there separately. And so if I take each of my factors and set them equal to 0, I see that I get this x equals 0 in there twice. So I have x equals 0 with a multiplicity of 2. Now my other x-intercept there is at x equals 3. So here I have x equals 0 with a multiplicity of 2. And that tells me that the graph touches the x-axis and turns around at x equals 0. So I'm just going to shorten that up a little bit and say touches and turns. At x equals 3, we only got that one time, so that's multiplicity 1, which indicates that the graph crosses the x-axis at x equals 3. So now we'll go ahead and find our y-intercept by plugging in a 0 for x, and that's just going to give us 0, which we already basically knew because one of our x-intercepts was 0, so that's the origin, which is also the y-intercept. The fourth step is to check for symmetry, namely check to see whether the function's even or odd. Since I have a mix of odd exponents and even exponents, then this function is going to be neither odd nor even. And so we don't have y-axis symmetry or origin symmetry. We may have some other symmetry, but just not those specific types. And so we don't have anything there that really would allow us to save some time in drawing the graph. So we don't have any y-axis or origin symmetry here. Okay, and the last step is really kind of a final check. So once I get the graph drawn, I'm expecting at most 2 turning points because the degree is 3. The maximum number of turning points is 1 less than the degree, and so we will make sure that after we draw it that we don't have any more than 2 turning points. So to complete the graph, we need to go ahead and plot the points that we have, which right now are the x-intercepts 0, 0, and 3, 0, and then the y-intercept is also 0, 0. So I could sketch something in here where it's down on the left, touches and turns at the origin there, comes back up somewhere else and crosses through 3 and goes up. To be a little more accurate, we should plug a couple other numbers in here for x and see what we get for y. So I'm going to make a small table here, and so some good choices for x to plug in would be like -1. Maybe let's plug in 1 and a 2 there, and then let's go ahead and plug in a 4. So I have gone ahead and completed that chart and plotted those points, -1, -4, 1, -2, 2, -4, and 4, 16 is basically indicating that this function is going to increase very quickly there on that side. So let's just go ahead and connect these dots in the way that's being indicated with all our information, and we'll see this graph. Okay, so we see on our graph it's down on the left, up on the right. We have it touching the x-axis and turning around at x equals 0, crossing through the x-axis at x equals 3, and we have 2 turning points, one there at x equals 0 and one down here when x equals 2, and so that fits our 5th condition there.